Okay, so in Unit 1, if you'll put your laptops away unless you're using it to follow the notes or something, if you have your book, this is the best way to follow on because all of this is in the book. If you don't, there's some scratch paper over there. On this blue piece of paper here, what I'd like you to do is just to write your name and fold it like this. That way the old teacher can get to know your names. Yeah, can get to know your names. There's some black markers that are laying around here. If you'll do that, that will help me try to learn your names in a quick fashion, okay? So let's talk about today. We're going to talk about two things today. Two ways of factoring. Factoring is a key thing that helps us to solve equations. And so think of factoring like it's like a bag of tricks. You try one trick and it works, maybe another one it works. So you just need to get proficient in that. So what we're going to do by the end of today, we're going to talk about these two methods. These two methods, the greatest common factor and the difference of squares. Now you should have seen these. How many of you had Algebra 2 last year? Okay. How many of you had STAT last year? Okay, it's about half and half. Okay. This would have been something that came in your Algebra 2. Should have been the last time you saw this if you were at Woodward. So one of the tricks that if it ever works, finding the greatest common factor is a key for factoring an expression. And factoring is the key for solving. So we're not doing factoring just because it's fun. We're doing because later it helps us factor. We will be doing factoring, you know, on and off until Christmas, you know, so it's a skill that you're going to need to, you can't just like, oh, I'll skip that part and I'll be better when things move on, but we're going to need to know this. So factoring out the greatest common factor. What does that mean to factor out the greatest common factor? Mm-hmm. Yep. You're finding out if I've got these two things, the greatest common factor will be the greatest thing that is common to what, both of these, right? Okay. That's what I'm looking for. Okay, so if I got 2x squared plus 4x, if I want to factor it, I want to find out what is in common to both of these. I got two things going on here. I have numbers and I have what? Variables. So I got x and I got the numbers. So let's break them up. What are the numbers that you see here? 2 and 4. Okay. What do both of those numbers have in common? 2. Because you've got 2 and then 4 can be written as what? 2 times 2. Okay. So you've got, this is 2 and that is 2 times 2. So I see 1, 2 right here, and how many do I see here? 2. So in common, how much do they have in common? They have 1, 2 in common, all right? So I can write both of those expressions have a 2 in common. Now let's look at the x's. How many x's are here? 2. How many are here? 1. So in common, they share how many x's? 1, okay? So that is the common factor, okay? Now I'm going to put a parentheses. What do I have to multiply 2x by so that I get 2x squared? X. Okay. I'm going to take that plus sign. What do I need to multiply 2x by so that I get a 4x? 2. That's factoring out the greatest common factor. Okay. So this can be written 2x squared plus 4x is 2x times x plus 2. Yes?
So why do we put like the 2's above it? Like what was that?
If you had something like this one, you could say, like, what if you had like, 18 and 24, and you're looking for the greatest common factor? Well, this is going to be what? That's 3 times 9. That's 3 times 3. This is 3 times 8. And that's 2 times 4. It's just the factorization. So what do they have in common? This looks like they have a 3 in common. That's all they have in. So if you look at it for the greatest common factor, so I'm looking at the factorization. So they,
The greatest common factor, like,
right, it's the greatest common factor. Okay. Yes. Where 3 times 6, you're right. So that's what threw you, right? Yeah, so 3 times 6, and then that's 2 times 3. And so if it looks like, oh, that's 3 times 2. Yeah, so the greatest common factor here is going to be 6, okay, because they each have a 3 and a 2 in common, okay? Okay, let's look at the next one, okay? I got the numbers and I got the variables. I like to just start with the numbers. I got a 9 and a 12. What do they have in common? 3. I've got 3 times 3 and 3 times 4. So I'm going to write down a 3. Now let's go to the x's. How many x's do you see here? X to the second, right? X squared, right? And then you have x to the first over here. So they share how many x's? 1. This one has 2 x's. This one has 1 x. So they have in common 1. Okay. So I take the lowest number of that. Yes. It would be x squared. They were both x squared. So let's look at y cubed and y squared. Here I have 3 y's. Here I have 2 y's. So I can say that they both have at least how many y's? 2. They both have 2 y's. Okay. Now I'm going to backtrack. What would I have to multiply a 3xy squared to get 9x squared y? So let's back up with a number. What do I multiply 3 by to get a 9? 3. What do I multiply x by so that I get x squared? X. What do I multiply y squared so that I get y cubed? Y. You guys got it? Minus sign. What do I multiply 3 by so that I get a 12? That's 4. What do I multiply x by so that I get x? 1. Okay, so I don't have to do anything there. What do I multiply y squared by so I get y squared? That's 1. So there we go. 3xy squared, 3xy minus 4. How could I check that answer? Yeah, multiply it back out. So you may not have time to always check your answer, but in algebra, you can always check your answer. If I multiply this together, I get 9, looks like x squared y cubed. All right, and multiply the other one, I get minus 12xy squared. Okay, so you can always check your answer there. Okay, the next one. Looking at the numbers, what do the numbers have in common? Right, I want the greatest common factor. 3 is a factor, but 6 is the greatest. This is 6 times 1, that's 6 times 3. So it's going to be 6, and then x what? How many x's do they have in common? 1x. How many y's? 1y, okay? Because it's x squared and x, so they have 1x in common. Y and y squared, they have 1y in common. Now I'm just going to backtrack. What do I multiply 6 to get 6? That's a 1. What do I multiply x by so that I get x squared? X. What do I multiply y by so that I get y? That's 1, okay? Bring the plus down. What do I multiply 6 by so that I get 18? 3. What do I multiply x so that I get x? That's 1. What do I multiply y by to get y squared? That's y, okay? So that is the greatest common factor. You have a question, Michael? Okay. Well, it's got 3 variables, but nothing's going to change here. I got these numbers 6 and 18. What's the common factor? I just found that a minute ago. What is it? It's 6. And then I just go letter by letter. Okay, I've got a squared and a cubed. What do they have in common? A squared. I've got b cubed and b squared. What do they have in common? B squared. C cubed and C fifth. What do they have in common? C cubed. Okay, that's my greatest common factor. Okay. Now I just need to figure out, okay, if I pull that out or I factor that out, what am I left with? So what do you multiply 6 by to get a 6? 1. And Jessica's question, well, can you just write that down? Yeah, if you need to, write a 1 down there. Yeah, that's fine. You can say, okay, that's a 1. What do I multiply a squared by to get a squared? 1. What do I multiply b squared by to get b cubed? B. Okay. What do I multiply c cubed by to get c fifth? C squared. Yep, you got it. And then I got a minus sign. What do I multiply 6 by to get 18? 3. And then what do I multiply a squared by to get a cubed? That's a. What do I multiply b squared by to get b squared? That's 1. C cubed to get c cubed, that is 1. So that's it, okay? So greatest common factor, this is the way we apply it. We have to look at both terms, figure out what is the greatest factor, the greatest thing that multiplies that they both have in common. couple more, and then we'll move on to the next method. Let's see, we are going till about, oh, that's not, is that right? We go to 1:30? I don't feel like that was, oh, so we're almost done. Maybe I'm just going slow today. Okay, if we don't get there, we'll pick it up tomorrow. Let's look at this. What do I factor out of here? What number? 4, what, a squared, right? And then I'm left with, what's 4a squared? What do I multiply 4a squared to get 4a squared? 1. So that's just a 1 plus 4 times what is 16? And then a squared times what is equal to a cubed? A, and then I've got a b there. So that's going to stick around, okay? And the last one here, 18 and 24, I think we're going to not get to this other method. What do 18 and 24 have in common? 6. So that's 6, and they have an x right there. And so what's left? What do I multiply 6x by to get 18x? 3 plus, what is it going to be, 4y. That's what we have there. And let's see. I think I will go ahead and pause here. So that's pretty much it for the greatest common factor. The next method we need to talk about in this section will be the difference of two squares, okay? So the nice thing about this method, guys, is it is a formula. So there are a lot of times we have to do a lot of work, but this is a formula. So if you ever see something like this, a squared minus b squared, that can be factored as a minus b, a plus b. So if you see something like x squared minus 4, that can be factored as you take the square root of the first term minus the square root of the next term, and then x plus square root of 2. I'm going to change this marker to a little bit lighter. So we have a formula. So you've got to know the formula and recognize it. So when I see something like 9 minus x squared, are both of those perfect squares? Yes, the square root of 9 is 3. The square root of x squared is x. So 9 minus x squared, difference of squares, that's 3 minus x, 3 plus x, okay? Let's look at 50x squared minus 32. Now, are these perfect squares? They are not. But this is where factoring sort of piles on, or it relates to using different rules at the same time. So for example, in this one, these are not perfect squares, but they're both even numbers. So there is a greatest common factor. So I could factor out a 2, and I would be left with what? 25 x squared minus 16. Now if I look at what's inside the parentheses, these are perfect squares. This is the difference of two perfect squares. So this is going to be 2 times, what's the square root of 25x squared? That is 5x minus 4, 5x plus 4. That is the complete factorization. But I had to use both methods that we talked about today. I had to use greatest common factor and difference of squares to get this one to work. Let's look at the next one, x to the 4th minus 25. Are those two perfect squares? Yes. So that is the square root of x to the 4th is x squared. So it's x squared minus 5 times x squared plus 5. Looking at the next one, x to the 4th minus 16. That's x to the squared minus 4, x squared plus 4. Now, if you'll look closely, what you see here, this x squared minus 4, that is the difference of two squares. So I can use this same rule again. So if I go back to this, this is going to be, that's x minus 2, x plus 2 times x squared plus 4. Now I do not have any rule for the sum of two squares. So this is as far as this one goes. The only rule that we've talked about here is when I see the difference of two squares. Let's look at the next one, 81y to the fourth minus 16. So the square root of 81 is 9. The square root of y to the fourth is y squared minus 4. That's the square root of 16. And then I get 9y squared plus 4. Now what you're always on the lookout when you see a subtraction and you see two terms, are they perfect squares? When I look at this first expression, that's a perfect square. So that's 3y minus 2 times 3y plus 2 times 9y squared plus 4. And that is our complete factorization. Now what you see here are the other terms. When you see a, I know it's probably messed up a little bit in your book, but this border that looks like these dashed lines, this is a point in the lesson that I sort of want to stop talking and let you work these problems. Okay, I'm going to go ahead today and just work through these, but in the normal course of a lesson, this is something that I want you to do. 4x squared minus 9, difference of two squares. That's going to be 2x minus 3 times 2x plus 3. X to the fourth minus 81. Difference of two squares. That's x squared minus 9, x squared plus 9. X squared minus 9. I can use the difference of squares yet again. This is x minus 3, x plus 3 times x squared plus 9. And there we go. 8x squared minus 2. These are not perfect squares. So the next thing I ask myself, is there a greatest common factor? They're both even numbers. So yes, I could factor out a 2, and I'm going to be left with, what do I multiply 2 by to get an 8? That's 4. So that's 4x squared minus 1. Now what's in the parentheses is a perfect difference of two squares. So this is 2, 2x minus 1, 2x plus 1. And that is our final answer. Let's look at the next one. It looks a little complicated, but we just break it down. This is not a subtraction, so it can't be difference of squares. It has to be the greatest common factor. Okay, so if I look at that, what is the greatest common factor here? It's going to be 12, but if you didn't see this, so you can have like 24. So let's just break this down. 24 is what? That's 2 times 12. 12 is 2 times 6, and 6 is 2 times 3, okay? 36, that's going to be 2 times 18. 18 is what? 2 times 9, and that's 3 times 3. So what do they have in common? So it looks like I see a 3 here and I see a 3 here. I see 2 2's over here, so I see 2 2's over here. So that's 2 times 2, that's 4. That's 4 times 3. So 12 is a common factor. You might have gotten that just by looking at them. This is 12 times 2 and 12 times 3. So 12 is my common factor. X. It looks like x to the first is my common factor. Y to the first and z. And then I'm going to be left with, what's 12 times what is 24? That's 2. X times x is x squared. Y times 1 is y, z times z is z squared, plus 12 times 3 is 36, x times what is x, that's 1, y times what is y squared, that's y, and z times what is z, and there we go. So 12xyz, 2xz plus 3y. So it looks a little complicated, but it's the same process. Common factor of the numbers and then of the variables. So this section, you need to be able to factor the greatest common factor, and you need to be able to recognize the difference of squares. Sometimes you have to do that particular formula twice in one problem, or sometimes a certain problem requires you to know the greatest common factor, then use the difference of squares. So you will have to use some of these things repetitively. So that's the end of section 1.1.